I hope all of you are doing good. Let's start today's chapter, Algebraic Expressions. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. In our earlier classes, we have learned some basic concepts and definition on algebra and algebraic expressions. Now we are going to learn some more operations such as addition, subtraction of algebraic expressions and some applications of algebraic expressions in solving problems of linear equations, mensuration, that is surface area and perimeter. Okay. Literal number. The letters of English alphabet which are used to represent numbers or replace numbers are known as literal numbers or simply literals. Let P be the perimeter of the rectangle, L represent length and B represent breadth. Then P is equals to what? 2 into in bracket length plus breadth. Similarly, if A represents area of rectangle, then A is equals to length into breadth, right? Algebraic expressions. We know algebraic term consists of some literals and some numerals. Okay, literal means alphabet, your letters of alphabets, and some numerals. For example, 5x is xy square, 7x square, yz, 14xyz and 3x, etc. An algebraic expression consists of two or more algebraic terms separated by the sign positive or negative, or you can say plus or minus. Thus, a 3xy plus 4y, comma 4x square plus 3xy plus 2y square, etc. represent algebraic expression, and in the expression 3xy plus 4y, 3xy and 4y are the terms of the algebraic expression. Okay. Factors of an algebraic term. We have already learned about factors of prime factors of given number. For example, the factors of 18 are as given below. See, these are the factors of 18. Also, the factors of 72 are given here. In a similar way, the factors of an algebraic terms are like this. You have 4x square y. So, 4x square is x into x and y. Okay. So, this is the factor tree of an algebraic term. Okay. Remember, in a tree diagram here, we are using continuous lines for terms and dotted lines for the factors. It will avoid confusion. Okay. Next, so now the factors of x square are x into x and x cube are x into x into x. Okay, here 1 is also a factor, but it is immaterial to write it, right? Next, coefficients of algebraic terms. To find the coefficient of terms of algebraic expression, we first separate the terms from the algebraic expression. Now, for example, in the expression, this expression, what are the, see, this is the expression, minus 8x square y plus 4xy plus 3x. So, in this expression, there are three terms. One term, okay, two term, and this is the term, three term, okay. And coefficient of x square, if we are talking about this term, coefficient of x square is minus 8y, and coefficient of y in this expression is, coefficient of y is minus 8x square, and coefficient of x square y is what? Minus 8. Okay. Similarly, coefficient of x in 4xy, coefficient of x is what? 4y, and coefficient of y is what? If we are asking about coefficient of y is 4x, right? And coefficient of x in 3x is 3, and numerical coefficient of x square is, in minus 8, x square y is minus 8y, and coefficient of x in term x is a simply one which is usually omitted in writing. Okay. Now, monomials, binomials, trinomials and polynomials. Polynomials. It comes from poly and nomials. In this case, meaning is many terms, so an expression having any number of terms is called polynomials. Monomials, binomials, etc. are the special cases of polynomials. Monomials. Algebraic expressions having only one term is called monomials. It is polynomial with one term. Thus, 3y square minus 2 and 5xy, etc. examples of monomial. Mono meaning one or single, right? Binomials. Algebraic expressions having two terms are called binomials. It is the polynomial with two terms. Thus, 3x square y plus 4y and 4x plus 5 and 7x plus 5y are examples of monomials by mean 2. Okay. Next, trinomials. Algebraic expression having 3 terms are called trinomials. Means this time there are 3 terms in the expression. Okay. It is a polynomial with 3 terms. Okay. As you can see in the example, 1, 2, 3. 3 terms, 1, 2, 3. Okay. So these are the examples of trinomials. A polynomial having 4 terms is called quadrinomial, and polynomial having 5 terms is called quantinomial, and so on. Okay. Remember, 1 is a polynomial with 1 term which is a constant. B, 1 by x or under root x or 3xy minus 2. 2 by x plus 2 are not the polynomials but x by 2, 3x by 8 and under root 2 are the polynomials. And C, polynomials can have constant variables with positive integral exponents. Okay. Now let's discuss like and unlike terms. Like terms. Algebraic terms having the same algebraic factors are called like terms. For example, 5xy minus 5xy, 17xy, xy are all like terms. Remember, to identify like terms, concentrate only on variables, ignoring the numerical coefficient and the sign of the term. Thus, 3xy and minus 3xy are like terms. Also, xy and 17xy are examples of like terms. Okay, unlike terms. Terms having different algebraic factors are unlike terms, like 3xy square, 3x square y are unlike pair. Similarly, these are also unlike terms. Okay, remember the numerical coefficient may be same, but the factors are not same in this example. Okay. Next, example 1. Write the following statement using variables, constants and arithmetic operation as algebraic expression. Okay. First one is subtraction of A from B. Subtraction of what? A from B. So this is the equation. Next, sum of two numbers x and y. Sum of two numbers x and y multiplied by z. Okay, or you can also put here a sign of multiplication, or you can also skip it. And number 3, half of a number x, that is x by 2, or you can also write 1 by 2x. Okay, so x by 2 is also correct. X by 2 added to twice of second number, what? Added to twice of second number, that is 2y. Okay. Example 2, identify the terms and factors in the following expressions. Okay, so how many terms are there? See, 1, 2. Okay, and then you find out the factors of these terms also. Okay, so 3x square plus 4y. Okay, so term is 4y, factors 4 and y. Okay, term is a 3xy square and factors 3x. And y square you have y into y. Okay. Similarly, you will do other examples also. Let's do exercise 12.1. Identify the like terms in the following. Okay. So let's see. X, y, z, comma 2xy square z minus 7xyz and 14xy square. Okay, so like terms, which are the like terms? xyz and xyz. So xyz and minus 7xyz, these are the like terms. Okay, and remember, don't forget to consider the sign while taking the coefficient. Example, if in this case 3xy square, coefficient of y square is minus 3x. Okay, and numerical coefficient is minus 3, not 3, right? Addition and subtraction of algebraic expression. Suppose we have 3 pens and we bought 4 more pens. How many pens do we have? Naturally 7 pens, because 3 plus 4 is 7. Now suppose you have 5 pencils and you buy 6 pens. How many pens or pencils do you have now? Can we add pencils and 6 pens and answer 11 pencils or 11 pens? No, it will be wrong to add like this. pens and pencils can't be added together in this way. Similar, in the case of addition or subtraction of algebraic expression, to add or subtract two or more algebraic terms, first we have to identify like terms and then we add or subtract these like terms as per the given numerical coefficient. Now adding 3x and 5x, what will we get? See, 3x plus 5x is equals to 8x. Okay, 3xy plus 4xy minus 8xy. 3 plus 4, 7xy minus 8xy, and 7 minus 8 is minus xy. We will not write 1. To subtract 5y from 9, 9 minus 5y is equals to 4y. Or to subtract 15x square from 10x square is what? Minus 5x square. If there are two or more terms in the given algebraic expression which are not like, and we have to add this to another algebraic expression of two or more different terms, then to add these expressions, first we recollect the like terms and add or subtract according to the numerical coefficients. Okay. Example 4, simply combining like terms. Okay. See, in this question, terms are given, so what we'll do, we'll combine like terms. Okay. See how. 3a minus 2b minus ab minus a plus b plus 3, okay, ab minus a plus b plus 3ab plus b minus a. Okay, so first we will write like terms together and then we'll add or subtract accordingly. 3a, then we have this minus a, and then this we have minus a. Okay, these are the like terms. Now let's move on to 2b. 2b plus b, and what else? Plus b plus 3ab, and we have this minus ab. Okay, 3a minus a minus 2a minus 2b, b plus 2b plus 3ab minus ab is 2ab. Okay, plus minus goes, 3a minus 2a is a plus 2ab. So this is the answer. Okay, similarly you will do b part also, right? Example 5, add. You have to add 3x plus 5 and 4x minus 6. So let's add 6x plus 5 plus 4x minus 6. We will first combine like terms, 3x plus 4x plus 5 minus x. 3 plus 4, 7x minus 1. Okay. Let's do exercise 12.2. Simplify the following combining like terms. 11m square minus 8m minus 4m minus 3m square plus 8m minus 11. So 11m square minus 3m square, then minus 8m minus 4m plus 8m minus 11. Okay. 11 minus 3 is 8m square, minus 8 plus 8 goes minus 4m minus 11. So this is the answer, right? Next, finding the value of an algebraic expression. We have already learned by now that the algebraic expression consists of variables and its value depends on the values of the respective variables. Similarly, in using various formulae in arithmetic, we simply put the values of variables involved in the formula. Area of rectangle is equals to length into b, L into b, where L is equals to the length of the rectangle and b is equals to the breadth of the rectangle, which you already know. If L is equals to 10 centimeter and b is equals to 9 centimeter, then area of rectangle is 10 into 9 is equals to 90 centimeters. Also, simple interest on a sum of rupee p at the rate of R% per annum for a time period of t years is given by this formula, that is SI is equals to p into R into t. Okay. If the values of p, R, and t are given, then the simple interest would be rupees 500. In a similar way, we can find the value of given algebraic expression when the values of variables involved are given. Okay, how? Let's do the example. If x is equals to 2, means value of x is given, so we have to find out the value of 3x minus 2. Okay, so value of x is what? 2. Value is given. So we will put the value of x as 2 minus 3. 3 2s are 6 minus 3 is what? 3. Okay. Similarly, in second part, 8 minus 4x. 8 minus 4, and what is the value of x? Value of x is 2. Okay. 8 minus 8 is equals to 0. Okay. Similarly, in this part also, you will put the value of x as 2. Okay. No more. All the formulae of arithmetic, of simple interest, compound interest, large profit area, volume are always expressed in form of algebraic expression. Okay. Let's do example 10. Here, value of a and b is given, and we have to find the value of, okay, value of a is 3 and value of b is minus 1, and we have to find out the value of this expression, plus 2ab square. Value of a is 3, so 3 square, value of b is minus 1, plus 2, value of a is 3 and value of b is minus 1. Okay, so 2 into 3 square is 9 into minus 1, plus 2 into 3 is a 6 and square of 1 is 1. 2 9s are 18 minus 1 minus 18 plus 6. Now minus 18 plus 6 is what? Minus 12. Okay, similarly you will do other parts also. No more. Take care of negative sign. Minus 1 power n, where n is odd, is equals to minus 1, and minus 1 raised to the power n when n is even is equals to 1, and minus 1 raised to the power 0 is equals to 1. Okay, if the power of any number is an odd number, then the value will be odd. Okay, and if the power is your even value, or the square of the value of a square will be positive only. Okay, and remember, if the power is 0, the value is 1 only. Okay, see, formula using algebraic expression. These are the parameter formula. Okay, see, if the L is the side, P parameter or parameter of equilateral triangle is a 3L, because an equilateral triangle has 3 equal sides. Okay, and perimeter of square is 4L, perimeter of pentagon which has 5 sides is 5L, and perimeter of hexagon is 6L. And area of a triangle is half into base into height. Okay, and area of rectangle is length into breadth, and area of equilateral triangle is this, under root 3 by 2 L square. L is the side. Area of a square is L square. Area of regular pentagon is area is equals to 5 into area of one triangle, and area of regular hexagon is what? Area is equals to 6 into area of equilateral triangle, that is 6 into under root 3 by 4 L square, where L is side. Let's do exercise 12.3. If x is equals to 3, you have to find the value of 2x minus 3. Okay, let's put the value of x, that is 3 minus 3. 2 3s are 6 minus 3 is equals to 3. So 3 is the answer, right? Next, rules for a number pattern. How many diagonals can be drawn in a quadrilateral from its one vertex? It is clear that only one diagonal can be drawn in this way. Okay, in this way. This is a quadrilateral because it has 4 sides. Let us check for number of diagonals drawn in a pentagon from its one vertex. Clearly the number of diagonals are 2. Thus we can write formula for number of diagonals drawn in an n-side polygon from its one vertex. It is n minus 3, where n is the number of sides. Okay, you can verify it for hexagon and heptagon and octagon also. Now observe the pattern given in the following figure. See this pattern. You can see that this pattern consists of the letter H. Letter H, you are noticing here. We need 5 segments of equal lengths to make this shape. For 2 shapes we need 8 segments, and for 3 shapes we need 11 segments. as you can see here, and so on. Let us try to write number of segments needed for n shapes. The number of segments needed are 3n plus 2. You can check for drawing 5 or more shapes. That number of segments needed can be calculated using 3n plus 2. Number of segment is equals to 3n plus 2 in nth pattern. Now observe the pattern given below. Observe this pattern. Here the shape is repeated. The number of segments required to form 1, 2, 3, 4 shapes are 3, 5, 7 and 9 respectively. If n is number of shapes formed, the number of segments needed can be calculated using the expression 2n plus 1. You can check it for n is equals to 4. That is for 4 shapes, the segments needed are, see, what is the formula? 2n plus 1. 2 into 4 plus 1, that is 8 plus 1, total is 9, which is clearly matching with the segments used in the figure, right? Let's do exercise 12.4. Number 1, observe the patterns given below. If the number of shapes used in n, then the number of segments needed to form n such shapes is given by the algebraic expression given in front of each pattern. How many segments are needed to form 6, 50, 100 shapes? Okay. So the formula is given 3n plus 1. Okay. So we have to find out how many segments are needed to form 6. So we will put here 6 plus 1. 6 3s are 18 plus 1. That means 19. 19 segments are needed to form 6. Similarly, you will find out for 50, 10 and 100 shapes. Right, students? And now you will do practice of the remaining questions.